Hello, my name is Miri, and I'm delighted to present to you today our paper titled The Progression of Disparities Within the Criminal Justice System, Differential Enforcement and Risk Assessment Instruments. In this paper, we study how the training and evaluation of risk assessment instruments is impacted by differential arrest rates. Let's unpack that. Risk assessment instruments are actuarial tools that are used in courts all over the world. In the US alone, they're used in over 1,000 counties. But what's their purpose? RI's primary goal is to predict the risk of reoffending if the individual is released. For example, if we release John without bail, is he likely to go and commit another offense? RAI vary, but they all share a common problem. They are not trained nor validate on offending data, but on past arrests. This means that their validity is strongly tied to arrests being a good, or at least equally good, proxy for offending. Relying on proxies isn't in itself necessarily a problem. When do we have a problem then? If, for example, the probability of arrest is higher for a specific subpopulation. Let's take, for example, two individuals who committed the same exact offense under similar circumstances. But the person on the left belongs to a subpopulation that is more likely to get arrested for the offense. That is a problem in its own right. However, it becomes an even bigger problem when you have risk assessment instruments trained and validated on these differential arrest rates. Because now, on top of this person being more likely to arrive at court in the first place, they are now also more likely to have worse outcomes within the court, such as being denied release on bail. So far, our discussion has been hypothetical. In order to ground it, we need to see whether or not arrest rates do depend on the person's demographics and to what extent. Based on the data we have, the answer is they do, but it does very much depend on the offense itself. For example, in this figure, we compare the rate of arrests from men who committed simple assault. You can see that there's a slight variation due to race and age, but it's within the error margin. On contrast, if we look at the arrest rates for drug use, you can see that they very much depend on both age and race. In this paper, we focus predominantly on differences in the probability of arrests due to the person's race. This is a good point to highlight that a negative effect of disparate arrest rates on risk assessment instruments have been hypothesized by many before us. But, to our knowledge, this has never been empirically demonstrated or quantified. What did we do? We used several US databases and we estimated how much higher the risk scores assigned to Black individuals were relative to white individuals who had a similar risk of reoffense, but not a similar chance of rearrest. In this work, we specifically evaluate these differences on risk assessment instruments with transparent algorithms. This means that we could not test COMPAS, for example, but we did test both the PSA and the VPRI, which are both popular risk assessment tools used in the US. We used real but anonymized arrest records from Harris County, Texas, that are part of the NULO dataset. We used this data source as it contains anonymized unique identifiers, which meant that we could construct anonymized criminal records for each individual in the dataset. We then conduct a counterfactual matching analysis. As a baseline, we match individuals with the same age and sex, but different race, who had similar arrest records. We then recorded the average difference between the risk score they were assigned by the different tools. You can see that there are small differences in scores even when comparing arrest records only, but they are quite mild. The exception for this is the VPRI, that even as a baseline showed differences in risk scores assigned to Black and white individuals. Then, we repeated the same matching analysis, but instead of using just arrest records, we also want to estimate the offending that led to arrests and the offending that did not lead to arrests. To do that, we need to estimate people's offenses from their arrest records. How can we do that? This is the approach we took. First, we estimate the overall offending within a demographic subgroup by taking the number of arrests within that group and dividing it with the prospective arrest rates. This gives us an overall number for offenses that have been committed by the group. Now, we need to distribute these unobserved offenses to the members of the demographic group within our dataset. We do this by assigning unobserved offenses at random, but we calculate individual weights based on the person's recorded offending, meaning their arrest records. By doing these, we generate the semi-synthetic offense record for each individual in the cohort. These records include real arrests and synthetic unobserved offenses. It's important to highlight that on an individual level, these are meaningless. There is no way for us to really know if somebody committed an offense from their arrest records. But our measurements are on the population level, so we do not need to be correct on the individual level. Putting all this together, what do we get? As expected, once you take into account offending and not just arrests, you see that black and white individuals estimated to have committed similar offenses are assigned significantly different scores. The first row is the absolute difference, and the second row is the increasing effect due to the synthetic offending part, meaning the baseline effect is subtracted. It's worth highlighting that these are percentage points, not percentages, meaning that for a risk assessment instrument with a scale of 1 to 5, this corresponds to up to half a point higher score on average for black individuals compared to white individuals. The existing data has a lot of limitations, and as a result, we had to make many modeling choices and assumptions when we conducted this work. Notably, we had to make assumptions regarding the relationship between arrest records and unobserved offending on an individual level. We had to estimate the arrest rate for each demographic group from national databases, knowing that arrest rates are likely to vary quite significantly locally. We also had to estimate the temporal relevance of arrests to offending, meaning that if a person was arrested for burglary 10 years ago, are they still likely to commit burglaries compared to if they've been arrested only a year ago? To test how robust our findings are, we did a significant sensitivity analysis, varying the different independent factors and parameters in our analysis. We found that our results were qualitatively robust, meaning that the effect was noticeable and significant under every set of parameters that we tried. Thank you very much for listening. If you found this interesting, please check out the full paper. A big thank you to my co-authors, Ricardo, Yuri, Bradley, Carolyn, and Adrian. Also, thank you to our funders, UKRI and the Leverhulme Trust.